Am I audible?
Yes, sir.
Yes, sir.
Okay. So let's start. Okay. So this is your lab 5. Basically, you will be covering your flow control instructions, something like jump, then what is conditional jump, what is unconditional jump, branching, looping. All these things actually you have already learned, but just not in assembly language. Like when you are in C programming, you have already learned about for loop, while loop, then executing some conditions like if else. So these are the things, these are similar type of things that we will be learning in this assembly language. Okay, so today's lab should not take much time, it is rather very simple. So let's start with the first one. Okay, all of you can already see the code, so let me ask someone to help me. Actually, that's a good practice, I believe. You guys are B2, right?
Sir.
Yeah.
Yes, sir.
Okay, you guys are B2. Okay, okay, okay.
Sir, I can help.
You can help.
Yes, sir.
What is your ID?
Sir, 088.
I love it. Okay. Okay, I love it. Can you tell me what do you think will be the output of this code? I mean, just asking. I don't expect you to answer, but if you can, that will be very good. What do you think? The code is given over here. What do you think will be the output?
Okay, sir. Let me think, sir.
Okay, let's do it together. Okay. So
Yes, sir.
we start. So we see that move H2 in this line. So what does this thing signify?
Sir, this moves 2 to the register H.
Okay, fine. So we are moving to, so let's write what we are doing. In AH, we have got 2, fine. Then in CX, we have got 256. So
Yes,
in
sir.
CX, we have got 256, fine. And in DL, we have got 0. Okay, when we have DL, we have got 0. Okay, this one looks like a label. Okay, this one is known as a label, like print loop, something ending with a colon. This is known as label. You will come across this once again. Whenever we execute int 20h in line number 12, what is the first thing your processor will do? It will check for the value in AH, right?
Yes, sir. Interrupt.
Exactly. So it will see that the value in AH is 2. So the meaning of the value in AH is 2 is it will prepare for a single character display. Do you remember that? We
Yes, sir.
put H2 for displaying a character. Where do we store the character? We store the character in DL, right?
Yes, sir.
So it will see that the value of DL is 0. So based on that value of DL, whatever is there in DL, it will display something, isn't it?
Yes, sir.
Then it will increment DL. So now your DL will become 1 and will decrement CX. So your CX will be 255. This is JNZ. JNZ means jump if not 0. Okay, so it will always check for the previous command. So is the value of CX 0?
No, sir.
It is 255. So it will jump in this line. Again, it will come to int 21h. Again, it will check for the value of h. The value is 2. Now the value of DL has become 1, right?
Yes, sir.
So whatever is the corresponding ASCII, it will print. Again, the value of DL will be incremented to, the value of CX will decrement to 4, 254. In this way, as long as the value of CX does not come to 0, you will keep on printing and you will keep on incrementing the value of DL. So at the end, say at some instance your CX is 0, has come to 0 at some instance. Now it will see that jump if not 0 to print loop. Now this condition will be violated. So if this condition is violated, instead of jumping, it will come to the following line.
Next line.
Yeah, so you know what will happen over here, and that will end your program. So if you look at the output, your output will be actually all the 256 characters that your microprocessor, in fact your assembly language can display, or your emulator 8086 can display. These are all your 256 characters. Of course there are some sounds like beep and all, that's why you cannot see all those things. Like you will find missing, like over here this one is missing. Okay, sorry. Yeah, you will find something missing. Okay, like see this place is missing, then over here we have got an enter, something like that. So these are basically, this might be some different sounds and all. So basically this is all an example of jump actually. Okay, now we will discuss everything about jump, but is it understood up to this?
Sir, I had a small
Yes, sir.
question, sir.
Yeah, yeah, say.
Small content. Sir, actually, I missed the last class, so
Mhm.
I had a one confusion
Hmm.
in the part int 21H, sir. So
Hmm.
you say that this indicates the register AH, right, sir?
Hmm, hmm, hmm.
So why is that? Is there a specific sequence for this? So if there will be int 21X, so it will indicate something regarding with the register
No, no,
CA.
no, 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 no. Your int 21h is known as an interrupt. Okay. After int 21h is a special operator like int 21h. It has a special function. It might have similar functions like that. So your int 21h executes a lot of built-in functions. Whenever you write int 21h, your microprocessor automatically checks what is the value in AH.
Okay, okay,
Okay,
okay,
it
sir.
is like, it is like an interruption. It interrupts your normal proceedings and it goes to some of its built-in functions.
So what if I wanted to see the value of a different register? So suppose CX or DL.
You want to see the value of C. In our first or second class, I think I told you something, that whenever you want to see something, that one must be in DL. That is mandatory. If you want to display something, it has to be in DL. It cannot be in any other thing. So say if you want to see something in CL, then before displaying, you need to move the contents of CL to DL, because for displaying only this one will be used, nothing
Yes, sir.
else.
Yes, sir.
Okay.
Okay, Arif, 34, Arif here.
Yes, sir.
So if you are asking about, I want to see what is inside that. So in emulator, you can see that. I do not know what is your question basically, but if you want to see the values, you can see in the emulator. And
Yes, sir.
also, if you have a hardware 8086, you can also check those values.
Yes,
But
sir.
if you want to print, then always it will be ASCII values, and that should be in DL, as your Arif sir has said.
Yes, sir. My question was that, sir, in 21H corresponds to the register AH. So, is there any other sequence like in regarding different other registers like CX or DL? So, there is none for them, right?
Okay, for in 21 is, that is age is fixed. So
Yes,
you
sir.
can find others also at the end of the book. There are appendix, and maybe we do not need all those things. Okay.
Okay, sir. Thanks.
Okay, so far.
Yes, sir. Yes, sir. Thank you.
Yes, sir.
Now we
Sir,
have got bolo. Any
in
question?
JNZ, it will always check the value of the previous line.
Your any jump instruction will always check the value of your previous instruction. You will come across the jump I have not yet started. This is just an example. Okay.
Okay, sir.
Okay, so in this code we had basically three queries. That is, why is AH initialized to 2? We already know the answer, right?
Yes, sir.
For single character display.
Yes, sir.
So which lines are used to display the characters? Which are the lines that we use to display the characters? Can you say?
Sir, int 21H.
Then there are some other lines. Actually, your all the lines from 10 to 15, they are responsible for displaying the characters. Because every time you are increasing or decreasing two registers, like you are incrementing DL and you are decrementing DX. So based on this, these two decides whether you will jump or not. So if you go to print loop, only then you will be displaying the characters. Otherwise, if you from line 15, if you go to line 17, you will not be printing anything. So basically line 10 to 15 are responsible for displaying the characters. Okay.
Yes, sir.
And which one is the loop counter?
CX, sir.
Exactly. CX is your loop counter. So whatever you put in CX, I mean, it is not mandatory that CX has to be the loop counter. In this particular example, CX is the loop counter. Instead of CX, you could have used BX or something like that. That is totally up to you. But for this particular example, CX is the loop counter. So this was, I mean, I wanted to start with an example of jump. Now we will enter in all the details of various types of jumps and all. Okay. Just I wanted to give you an example at the very starting, just to show you that this is not that difficult. Okay,
Yes,
let's
sir.
move on. So there was something I talked about label. Remember, like print loop was the label, right?
Yes,
So
sir.
labels are needed in situations where one instruction refers to another. Like let's go to the previous example. Look at line number 15. So this line number 15 itself is an instruction, but this is referring to another instruction located in line number 10, right?
Yes, sir.
So for that reason, we need labels. Like we will call the label and your processor will jump to the label. All right. So this is known as label. Labels normally end, not normally, labels always end with a colon. And it is a good practice to represent labels in a single line, because then it becomes easier for you to see or to write the code to see where the label is. Like in our previous example, we had only one label, but it might happen that you have 5 or 6 labels, you have a very big code. So if you keep your labels separate in a single line, it becomes easier to identify, and thus you can use it comparatively easily. Clear up to this?
Yes, sir.
These are very simple, okay? Nothing complicated. In today's lab, actually there is nothing complicated. Fine. So
Sir,
there are
is label the same thing as name?
no, names normally do not end with a colon.
Okay, sir.
Labels will end with a colon. Like over here, if you go for name, like main is a name, right, Robiul?
Thing is that label, the name that we are using in the label is a name field. That is the thing. I should say, like the variable name, it is a label name. Are you getting
Yes,
me?
sir.
Yes.
Yes, sir.
So label is a specialized name, we can say, right? Something
Yes,
like
yes,
that.
yes.
Okay. All right. So there are two types of jump: conditional and unconditional. As you can see, the name suggests, if there is some condition imposed, then that is a conditional jump. If there is no condition imposed, then that is an unconditional jump. Now, can you say the jump that we just executed in our previous example, what was that, conditional or unconditional?
Conditional, sir.
Exactly, that was conditional because it checked some condition. Okay. And there is another which we will see, which is unconditional jump. Now look at conditional jump. The syntax is j will be fixed. After that, you can see that we have written x x x. Actually, now you will see, like in the first example, it was z and z. So instead of xx, we use jump if not 0. So similarly, we can put a lot of things after j that will define various type of conditions, which you will come to know.
Yes, sir.
Now, these two are quite important to understand. See, if the condition for the jump is true, the next instruction to be executed is the one at destination level. So if we go with our previous example, we had jump not 0 print underscore loop. So if this condition is satisfied, that is true, then your processor will move to this label, wherever this label is. It will go to this destination. But if, look at this, if the condition is false, then it will not jump, rather it will come to the next instruction, whatever is following. Is it understood up to this?
Sir,
Okay.
could you explain with one example?
Okay. Like let's take this example. Okay, let's take this example. See what that slide is saying basically. If this condition jump, this condition, if this condition is true, your microprocessor will jump. So the next line that will be executed is the first instruction within the loop, provided the condition is true. But if the condition is not true, then your microprocessor will not jump, rather it will execute whatever is there after the instruction of the jump. I mean, the next instruction which is there after jump will be executed and it will not jump. But if the condition is true, then it will jump to the loop and the first instruction within the loop will be the next instruction.
Yes, sir.
Is it clear up to this?
Yes, sir.
Okay. If you understood, now tell me, if we had something like this, jump not 0, then print underscore loop, same line, and we have the loop over here, print loop, then we have got the body. What will happen then? If the condition is true, where will your processor jump?
Move.
Exactly.
Next lines.
It will jump to the next line. But if you do not have within the body of the loop something that will bring your processor back over here, then this loop will never be printed again. Did you get my point?
স্যার এই কথাটা আরেকবার একটু বলুন।
আচ্ছা see, whatever is there, you have written jump not z print loop. So if the condition is true, your processor will jump over here, I mean the following line.
Yes, sir.
then it will keep on executing whatever is there within the loop.
Yes, sir.
Now finally, say you are ending the loop, you are writing main end p and then end main. So what I'm saying is that this loop will be executed only once, because you have nothing that tells the microprocessor to get back to this line. I mean, if you do not come to this line, then this loop will never ever again be printed.
Yes, sir.
Did you
Yes,
get the
sir.
point?
Yes, sir.
Yes,
say,
sir.
say if we had another label over here, like say we have a label over here do, and within the print loop we have something like jump do, say we have something like that. So what will happen? Then it will execute the body of the loop, then it says jump do. Now your processor will jump over here, then again it will come. Okay, you will see all these things gradually. Okay, let's move on. You will see all these things gradually. Okay, so there are two types of jump, conditional and unconditional. So this was the conditional jump. So these two things are clear. If the condition is true, the next instruction will be in the destination level, and if the condition is false, then it will, whatever is the following instruction, that will be executed.
Yes, sir. It is clear, sir.
Okay, now look, these are the jump in instructions for signed numbers. These are conditional jump, okay, not unconditional. These are conditional jump instructions. This is the important part over here. These are for unsigned. Okay, now
Yes, sir.
you can see that this jump if equal, jump if zero, the description is written jump if equal, jump if zero. As I already said, all this will check the previous instruction. Whatever is your previous instruction, based on that these things will execute. So jump if equal, jump if zero. Now you can see some conditions over here. These are not our headache. I mean, based on the flags, these are what your processor determines the operation. I mean, your processor understands that whether this condition is true or false based on these flags. If we understand these portions, then we do not need to know what is happening in the flags. The flags will automatically happen like that. Okay, so for the time being, I will ask you not to concentrate on these things, but still I have shown you this thing so that you know that how does the microprocessor determine all these things. How does your processor, because your processor does not understand these things, that jump if equal, jump if zero, something like that. So your processor takes the help of various flags. So this is something we do not need to bother for the time being. We are just interested in the left hand side, the instruction and the description. So these are the opposite instructions. So jump if equal, so Zn is jump if not equal. So Jz is jump if zero. So Z and Z is jump if not zero. Same thing, jump if not equal, jump if not zero. Okay, jump if above, jump if not below or equal. Okay, look at this. There is a slight difference between these two. Jump if above and jump if not below equal. Like this one will only check if the value is above or not.
Yes, sir.
But this one will also check whether it is equal or not. Like not, below and above is basically the same thing, but over here you have got an extra condition that is equal, and you can see the sign jump if above, jump if not below or equal. Clear?
Yes, sir.
Yes,
Same
sir.
thing.
Equal
Jump
to what value?
हाँ बुझी नहीं.
Equal to what value?
Exactly, it will depend on the previous line. Like suppose you are writing compare, then say you are writing ax comma cx, something you are writing. So now it will, now you are writing jump if above then something. So what is the meaning? Jump if above. So ax is being compared with cx. So if ax is above cx, then it will jump. Otherwise, it will not jump. I mean, jump if above.
Okay, sir.
Okay, you'll see the examples. Don't worry, you'll see the examples. Then jump if below, jump if not above or equal, jump if not. All these are things are equal. Jump if below or equal, jump if not above. All these things are very simple. Is it understood, the jump instructions? So these are your jump instructions. Okay, conditional jump.
Yes, sir.
Let us
Yes,
take
sir.
examples. Okay. Bolo.
Understood, sir.
Okay. Now let us take the examples. All right. So this is the first code. Okay. So let's see what is happening. So before showing the output, let us try to predict the output. Then we'll see. Okay. So move AH2. Okay. In AH we have got 2. In DL we have got an equal sign. Fine. BL has got 6. So let's write over here. So in BL we have got 6, in CL we have got 4. Okay, the following line int 21h. So int 21h will look for the value in AH. The value in AH is 2. So that means it will prepare for a single character display. All right, so a single character display. So it will check for the character in DL. The character is equal. So an equal will be printed first of all. Now it will increment CL. So CL will now become 5 and it will decrement BL. So BL will now also become 5. It will compare BL and CL. Now jump if equal print loop. Are the two values equal?
Sir, BL and CL is equal, sir. Yes, sir.
So
Yes,
it will,
sir.
as I said, it will check for the condition in the previous line. So jump if equal. So BL and CL are indeed equal. So it will again jump to this loop. Again, it will come to line number 13 from here. It will come over here. So in 21H, we'll see that the value in AH is 2. So it will prepare for a display and it will move to DL. The character in DL is again equal. So another equal will be printed. Now it will come to this line. CL will be incremented by 1. So CL becomes 6 and BL will now be decremented by 1. So BL becomes 4. Now it will compare BL and CL, whatever we get. Jump
Yes,
if
sir.
equal. Now is it equal?
No,
No,
sir.
sir.
No, sir.
It is not equal. So it will come to this following line.
Yes, sir.
X will be moved to the register DL. So now in 21H will again be executed. So in 21H will check for the value in AH. Again it will see that the value in AH is 2. So whatever is there within DL will now be printed, right?
Yes, sir.
So
X
what
will
is
be printed.
exactly? So now X will be printed. Then it will move AH to 4 stage. This will just transfer the control and your program will end. So let's look. This is the output. So you are getting 2 equal and a cross sign. Is it understood up to this?
Yes, sir.
Yes, sir.
Any question?
No, sir.
Sir, why did we get the cross sign, sir? Can you repeat?
Yeah. See, look at line number 18. Look at line number 18.
Yes, sir.
So, okay, wait. Okay. So whenever this condition will be false in line number 17. So if the condition is false, your processor will execute the next instruction, right?
Yes, sir.
So in this next instruction, you have moved a cross sign into DL, and then in line 19, you have again executed int 21H. So every time you go for int 21H, it will check for the value in AH. So in
আমি
AH,
কি
the value is 2, and it will check for the, if the value in AH is 2, it will check for the value in DL. So now what is the value in DL?
Sir, X.
X. So now that will be printed. Robil কিছু বলছিলি?
না না আমি আমি কিছু বলি নাই কারণ
Okay.
মাইক হয়তো অন হয়ে গেছিল
আচ্ছা আচ্ছা. Okay. So is it clear up to this?
Yes, sir.
Exactly. It will always check. Yeah. So it needs to be a meaningful line. Like if you are writing decrease BL and if you are writing jump if equals, then equal to what? That is a question, right? So that's why most of the times you will see that your jump instructions are preceded by compare instruction, because that is what makes sense in most of the cases. Yeah. So yeah, that is a meaningful, what I can say, that is a meaningful scenario with J and Z, because jump if not 0. So decrement is, I mean, it goes with that instruction because it will check whether it is equal to 0 or not, right? No. It will not check the CX register. Like I said, your jump instructions are not related with any register. In that example, I told you, your CX is not mandatory. You could have taken any other register, no problem with that. Like in the previous one, which you are saying, we had decrement CX and then we had jump if not 0, right? So instead of CX, you could have written anything over here. Like you could have written BX also, no problem with that. You could have written BX also. So jump not 0 will always check what is there in the previous line. So if in the previous line you had decrement bx, then it will check whether bx has become equal to 0 or not. Get my point? Exactly. Yeah, it will check for the bx. Is it okay? Okay.
So in this problem, which is the loop counter here?
In this problem, which is there, I mean, BL and CL both actively take part as a loop counter now, because you are comparing two registers at the same time, BL and CL, and they both play an important role in determining whether it is going to the loop or not. Actually, frankly speaking, this is not a loop. This is a jump instruction. You will come to see what is the loop. I mean, see, in C programming, you had if else. Do you remember that if this, then go over here, or else? This is something like that. This is something like if else. So you are executing all those things over here.
Yes, sir. Understood.
Get my point?
Yes, sir.
Okay, ID 009. Are you there?
Yes, sir.
So did you understand?
Yes, sir.
Are you sure?
No, sir, not sure, sir. Sir, I was not near my laptop for a while.
You don't need laptop. Did you understand this example or not? Just tell me.
Sir, yes, a bit.
Okay, which portion do you have confusion? Tell me. Do you have confusion in any line?
Sir, I understood.
Okay. If you understood, tell me what will be the output of this code.
Sir, the second one.
Yeah, the second one. The other students can also do it by yourself, but don't tell me the answer. Only 009 will tell me the answer. If she can't, then I'll move to others. Okay, but you can try to solve it on your own. What will be the output of this code? Simple.
Sir, what is the jump instruction? Mane full form, sir. JNA.
Sir, is it, sir, jump if not above?
Exactly. JNA is jump if not above. Okay.
Yes, sir.
So this is JNA is jump if not above. So remember, this is equivalent to your class performance 009. So make sure you answer, okay? Don't take too much time. Bolo.
Sir, equal হবে একটা first এ।
আচ্ছা, ফার্স্টে একটা ইকুয়াল হলো, তারপরে
Sir, then cross।
দেন ক্রস, আর কিছু?
No, sir.
Okay, let me go to wait. Let me see. 93. Are you there, Abir?
স্যার আবিদ স্যার ওর আম্মুকে নিয়ে একটু ডক্টরের কাছে গেছে স্যার।
আচ্ছা আচ্ছা
স্যার আন্টির অ্যাপয়েন্টমেন্ট ছিল আজকে।
ওকে ওকে,
আমাকে মেইল করছে।
আচ্ছা আচ্ছা, সমস্যা নেই। ওকে, 103 আকাশ, আর ইউ দেয়ার? Akash, are you there? আকাশ নাই রবিউল?
এখানে দেখতেছি না তো।
আচ্ছা, তাহলে হচ্ছে ওকে, 118 Fariha, are you there?
আচ্ছা আচ্ছা
118 Fariha. কি অ্যাবসেন্ট নাকি রে রুবেল?
না এখানে আছে তো প্রেজেন্ট আছে
আচ্ছা রেসপন্ড না করলে I will take that as a no. Fariha, are you there? Okay, not responding. Okay, 141 Samadul, are you there?
141
সামাদুল আছে
দেখতেছি না তো
আগে সবগুলো তো অ্যাবসেন্ট ছিল ওকে ফাইন 144 Alvi.
Yes, sir.
So whatever your friend Alice just said that your output will be equal and a cross, so do you agree with her or do you have a different opinion?
স্যার আমি স্যার JNA স্যার এই কন্ডিশনটা স্যার মানে এই লাইনটা স্যার মানে একটু ক্লিয়ার না স্যার মানে এই কমান্ডটা স্যার মানে এই জন্য স্যার বলতে পারছি
আচ্ছা জাম্প ইফ নট অ্যাবভ এটার মানে কি আমাকে বলো বাংলা মানে কি
স্যার যদি উপরে না থাকে এটা এরপর তার উপরে কি না থাকে স্যার উপরে কি না থাকে এটা তো মানে বুঝতে পারতেছি না স্যার এই জন্য
আগের লাইনের ইনস্ট্রাকশন অনুযায়ী ওকে ফাইন
স্যার এই লাইনটা একটু ক্লিয়ার করে দিলে স্যার মানে বুঝতে পারতাম স্যার
এই লাইনটা ক্লিয়ার করে দিলে পারতা ওকে এনিওয়ান who can
Sir, I can try, sir.
34 can I try
192, sir.
wait 34
145, sir.
I'm gonna try sir
okay 34 Muntasir okay bolo
so since the code is jumping if not above so first there will be a equal and then there will be another equal so the since it will be decreased to 6 and the next one will be increased to 5 so this will also execute the command jump if not equal and go back to
the condition
first.
is the condition is jump if not above.
Yes sir.
So initially okay wait initially wait we have BL equal to 7 and CL is equal to 4 right?
Yes sir. Yes sir.
So once this first one is executed equal then increment CL so CL will become 5 and BL will become 6. Now when you come over here compare BL CL jump if not above so now what will happen tell me
jump if not above since so jump if not above since these are still above sir okay so this will go to the next command number 18 because it is actually above 6 and 5 6 is above 5 so go to the next one so since we have moved DL x so this will just be an equal to x
so what you are saying is we'll have 2 equal and then cross
yes sir
okay there will be only one equal and
sir,
cross.
sorry sir one equal and cross sir not 2 equal one equal and cross
okay now tell me why there is only one equal and cross tell me
sir because sir we see sir at first there will be a single equal because it's actually given in the line number 7 and since the after the execution of the condition increase and decrease 6 and 5 we see that we need to jump if they are not equal so as they are not equal
no it is not
above.
equal it is
yes,
not
sir,
above
not
yeah
Above,
not
yes,
above.
sir.
Since it actually they are above so we need to go to the next statement which is the
wait they are above what who is above what
BL and CL
yeah above what so you are comparing these two so above means what
Sir, is it
above.
like, sir, BL is above CL?
so if BL is
Yes,
above
sir.
CL the condition is true
Yes, sir.
yes sir
so what is the condition is jump if not above
No,
right
sir, not above,
not
sir. তাহলে sir
above, sir. তাহলে
less
তো-
than CL হতে হবে, sir.
exactly but in fact what is that in fact BL is above CL right
yes
but
sir
the condition is jump if not above so the
Not
condition
above.
is becoming false
yes sir
so it will check I mean someone had a question okay so it will look at this question now trying to understand what this compare does your compare is basically BL minus CL right
yes sir
if you remember from your previous class your compare means what BL minus CL
Yes, sir.
so when you are writing jump if not above that means you are saying whether BL is above CL or not so if
Yes, sir.
BL is above CL your condition is false if BL is below CL then your condition is true
Yes, sir.
yes
so
sir
whatever 009 said she is actually correct I don't know whether she understood or not but she got the right answer
yes sir
okay so কে জানি তখন কোশ্চেনটা বুঝে নাই আলভি রাইট
yes sir
So do you understand now? Okay. So Alvi, now tell me what will be the output of this one. Others can try on your own, but let Alvi answer.
স্যার জেবি দিয়ে কি বুঝাইছে একটু বললে?
Jump if below.
Jump if below. Okay.
Yeah, just apply your common senses. Okay, it will always be exactly like that. B is below, so jump if below.
স্যার দুইটা ইকুয়াল সাইন হবে স্যার, এরপর ইয়া হবে এক্স হবে।
দুইটা equal sign এরপর x. Okay, help me explain. I mean, just explain me. So initially h is 2, dl is equal. Fine. In bl we have got 7, so let's write in bl we have got 7, and in cl we have got 4, right?
Yes sir.
So tell me what will happen in line number 13. 1 equal will be printed, right? This much I think
Yes,
you
sir.
understood. Okay.
Yes sir.
In line 14, cl will be incremented by 1, so cl becomes 5. Then in line 15, decrement bl. Bl becomes 6. Now compare bl and cl bl. So we will compare cl and bl. So this one
CL
is basically cl minus bl, right?
Yes sir.
Now jump if below. That means if what? Tell me.
If CL is less than BL.
Exactly. If cl is less than bl, so the condition is true, right?
Yes sir.
So now this one was already printed. So now this one is being printed in this line, right?
Yes sir.
Now again we will increment cl, so cl will become 6. Decrement bl, bl will become 5. Now it is saying compare cl bl. Okay, now jump if below. So now the condition is being violated, right?
Yes sir.
So this is what you are saying. Yeah, so we are getting equal, equal, and cross. So is it understood, everyone?
Yes, sir.
Yes sir.
Anybody,
Yes
any
sir.
question? So
Clear, sir.
if you understood, I mean, this is everything about conditional jump. I mean, now you know everything about conditional jump. Like, we can go to the previous slide. So these are the things. We took 3 different examples. So rest of the things are also pretty similar. Is it okay?
Yes, sir.
Okay, so these were your 3 examples. Now let us move for another thing. If you remember, that was those instructions were for unsigned numbers. Now these are for signed numbers. Now this is what is very important. Now you'll see that this instruction, these are same. Okay, there is no difference between signed and unsigned. The difference comes in these instructions. Like over here, jump if greater, jump if not less or equal. Jump if less, jump if not greater or equal. Jump if greater or equal, jump if not less. Jump if less or equal, jump if not greater. If you remember, in for signed cases, for jump if greater, we had jump if above. Do you remember? For J and LE, we had jump if not below or equal, right? Do you remember? These were for your unsigned cases. So for unsigned cases, you will use above and below, but for signed interpretation, you will use greater and less. All right. So if you ever write jump if greater, your processor will automatically understand that you are going for signed interpretation. So it will also go for signed interpretation. If you go for jump above, your processor will understand that you are going for unsigned interpretation. So it will neglect the sign and it will go for unsigned interpretation. Same thing for jump low or jump less or jump not less. Okay, up to this?
Yes, sir.
Similarly, you don't have to worry about the conditions. Okay, just forget about the conditions because this is something your processor will do within itself. So if you understand the description, that is enough for us. We don't need to know the flag status. And these are as usual the opposite instructions. Okay. I mean, let's take an example. Okay, so let's solve this one. So see, I have tried to keep the example similar. Okay. Let's see the output, then we will try to see. All right. So initially in H we have got 2. All right, fine. Initially in DL we have got an equal sign. BL is -7 and CL is -1. So now we are in line number 13. Whenever we execute line number 13, that is int 21H, it will check for the value in AH. So the value is 2. So that means it needs to display a single character from DL. In DL, it has an equal sign. So your output will be 1 equal. Now, increment BL. So if I increment BL, what will be my value? Tell me.
-6.
-6.
Exactly, it will be -6. And decrement CL, what will be the value in CL?
-2.
-2.
-2. Now I will compare BL and CL. The condition is jump if less or equal. So tell me, is the condition true or false?
True, sir.
True?
Yes.
Yes, sir.
Of course it is true. Jump if less or equal. That is whether BL is less or equal from CL or not.
It's less, sir.
So CL is -2, BL is -6. So BL is less than CL. So the condition is true. So again, it will come to line number 13. Another equal will be printed. Again, you will increment BL. So now BL becomes -5 and CL becomes -3. Is the condition true now?
Yes, sir.
The condition is true. So another equal will be printed. And it will be -4. It will be -4, right? Now tell me, is the condition true or false?
True, sir.
Exactly, it is true because there is also one E over here. So it will also check whether it is equal or not. So
Yes.
equal means the condition is also true. So another equal will be printed. After that, this will be -3 and this will be -5. Now is the condition true?
No, sir.
So the
No,
condition is
sir.
false. It will move to the next line. Across will be this and that will be the end. So look, so you will get 4 equals and a cross sign. And this is the explanation. Any question?
No, sir.
Everyone, is it clear?
Yes, sir.
Yes, sir.
Okay, let's move on. Now let's see a signed versus unsigned jump. Okay, let me go to, okay, who can tell me the output of this code? All of you can try on your own. There is a small trick. Try to remember, okay? This is not as easy as your previous ones. So the floor is open. So anyone who can answer, just let me know. Do not answer, but let me know.
Sir, can you please say what is the jump JG indicates, sir?
Jump if greater. JG is jump if greater.
Sir,
Jump if greater.
sir, JG will be for signed numbers, right?
Yeah, greater and less is for signed interpretation.
Sir, I can try.
কত আইডি
088.
088 আলাভি আচ্ছা বলো কি হবে
Sir, BX, the leftmost value is
just tell me
7.
the output. Just tell me the output. Don't explain. Just tell me the output.
Sir, it will be,
বলো আমি লিখছি তুমি বলো আমি লিখবো
sir, I understood the process. So compare if greater BX is greater than CX. So
Okay.
it won't print.
Okay, so just tell me the output.
Sir, no output.
Nothing.
Sir, can I answer
Sir,
one?
can I try?
Can I answer?
Okay, wait. Okay, since these are open question, I'll not take negative. Okay, ID bolo.
Sir, 48, sir.
48, Asif, okay.
Sir, X, only one cross, sir.
Only one cross.
Sir, can I answer?
Wait. Only one cross. Okay, কত আইডি কত আর কে?
Sir,
145, sir.
ওকে, এটা কে বললো শুধু only one cross হচ্ছে 48 তাই না?
Yes, sir.
Okay, this is 48. হ্যাঁ, আর কে বল আইডি বলো, আইডি কত?
So 115.
145, sir.
ওকে, 115 ছিল, আর কে আছো?
145, sir.
হ্যাঁ 35 না কত বললো?
34.
ওয়েট আচ্ছা হ্যাঁ 34 বলো, মুনতাসির বলো।
145, sir.
Sir, 30. It will be an equal to and x.
ইকুয়াল টু এন এক্স, এটা
Yes.
হচ্ছে 34। আচ্ছা, আর একজন জানি কি বলতে চাচ্ছিল?
145, sir.
145 তৌফিক, হ্যাঁ বলো।
Sir, equal and x, sir.
আচ্ছা 34 and 145, okay. You think it will be equal and x? Anyone else with any other answer? Are you with any other answer? Anyone else? I've got two answers. 48 says there will be only one cross, and 145 and 34 said there will be an equal and then a cross. So anyone else with any other answer? কত আইডি কত? 134 Imon. Okay, so according to 134 it will be infinite loop. Let's see. Yeah, it is an infinite loop. So can anyone, so 134, since you gave the correct answer, tell me why is it becoming an infinite loop? Okay. Exactly. Did the rest of you understand?
Yes, sir.
Yes, sir.
No, sir.
Sir, I
Sir,
understood
can you
the
explain,
same thing.
please?
Okay, I will explain it a little bit later. Okay, I will explain. Now tell me the output of this code. I will explain, don't worry, I will also explain. But for the time being, 134 only got done marks, okay? So again, the floor is open. So you can try. There is no negative marking or something like that. You can try.
Sir, can I try, sir?
What ID bolo?
Sir, 138.
Wait, I'll try to give some people 138. Okay, 138, go.
Sir, it will just be a cross.
Sir, now, sir.
Okay, wait.
Can I try?
Wait. According to 138, it will just be a cross. Okay, next.
Sir, 109. Sir, 92, sir.
Okay, wait.
Sir, 144, sir.
Okay, I will go for 109 first. Okay, 109 bolo ki hobe?
So it will be an equal and cross.
Equal and cross. আচ্ছা তারপরে আর কে?
স্যার আমি বলতে চাইছি।
বলো আইডি বলো।
স্যার আমার সেম অ্যানসার স্যার, ইকুয়াল এন্ড ক্রস।
আইডি কত?
স্যার 92, স্যার।
Okay, 92 also same answer. Anyone else?
Sir, 145, sir.
145 বলো কি হবে?
Sir, equal and x, sir.
Remember, you also need to know the explanation if provided if I ask. That's why I'm writing the IDs.
34 also equal and x.
34 also equal and x. Okay, let's look at the output. It is equal and x. Okay,
Yes,
so
sir.
I will give numbers to all of you. Don't worry. Again, number ta diye nahi daro. 34 Muntasir, right? Okay. Muntasir, then 145 is Tofik. 92 is Sakib. And finally 138. 138 so 138 is also Sakib. Okay.
Sir, 109.
Oh, 109 chilo.
Sir, I have given the wrong answer, sir.
Oh, 138. Yeah, you have given the wrong answer. Okay. Anyway, don't worry. No problem. 138. Yeah. Okay. To look at the example, we need, okay, before that, just see that in these two codes, what is the main difference? Just tell me, where is the difference?
স্যার সাইন এন্ড আনসাইন।
Exactly. In line number 15, just say, apart from line number 15, in both the codes, everything is exactly similar. But line number 15 also signifies the same thing. One thing says that JG is jump if greater, and another says that jump if above. So they mean the same thing, but the interpretation is different. So now see what is happening. What are the two numbers? one of the number is 7FFF and another number is 8000, all are in hex. So if you convert them, look at the signed and unsigned interpretation. So when you are saying jump if greater, it will go for signed interpretation, right? Are you guys getting me? It will
Yes,
go
sir.
for signed interpretation. And what are the values? In this is the value stored in BX, this is the value stored in CX. What are you comparing? You are comparing BX minus CX. So now see, when you compare BX and CX and you are checking whether BX is greater or not. So the value of BX is 32,767 and the value of CX is minus something. So definitely the value of BX is greater than CX. So it will go in this loop. Once you enter in this loop, see, you are not touching the value of BX and CX. I mean, you are not incrementing or decrementing. So these values will always remain this one and this one. That's why you will end up getting an infinite loop because you are not changing the value. Is it clear to everyone?
Yes, sir.
Bujha gেছে?
Yes, sir.
Okay. Now come over here. When you are writing jump above, it will go for unsigned interpretation. So these are the two numbers that it will check. So it will check whether BX is above CX or not. So BX is 767, 32,767 and CX is 32,768. So the condition is false, isn't it?
Yes, sir.
Because it is not above. Jump above, the condition is false because BX is not above CX. BX is below CX because CX is smaller than CX, isn't it?
Yes, sir.
So since the condition is false, it will directly move to line number 16. But in line number 13, it will print 1 equal at the very beginning. It will print 1 equal, then it will compare. Then it will come to line number 15. It will see that the condition is false. So it will move to line number 16. Then in 17, it will print 1x and it will execute. I mean, it will exit. Is it okay?
Yes, sir.
Yes, sir.
Any question now? Please ask if you have any question.
স্যার আমার স্যার স্যার H2 এবং DL এই দুইটা স্যার আমরা কেন ইউজ করতেছি মানে মানে এটা লুপের মধ্যে কোথায় লাগতেছে?
H2 DL হচ্ছে int 21H এর সাথে রিলেটেড। আমি জানি না আগের ক্লাসগুলো করছো কিনা। তুমি যখনই whenever you will go for int 21H, the first thing your processor will do is it will check what is the value in AH. It will check if the value in AH is 2, only then it will check what is the value in DL. Otherwise, it will not check the contents in DL.
Okay, sir.
Similarly, we have got, if you have in AH1, then there is another. If you have got 9, then there is another. So check the previous classes, okay? These are all related to previous classes. Up to this, is it clear?
Yes, sir.
Any question?
No, sir.
No, sir.
Okay, so let's move on. Now, these are simple jump instruction that test single flag. Like, if you look at the previous examples, you see that we normally had two conditions. I mean, we had two registers. We were comparing. But look at these instructions. This compares for the single flag only, like jump if 0, jump if equal. Of course, you need to specify equal to what. Then jump if carry, jump if sign, jump if overflow. I mean, very simple. Jump if parity even, not 0, not carry, not sign, not overflow. Simple. I mean, there is nothing complicated over here. Do I need to explain any of this? You can ask me, no problem.
No, sir.
Like, these are rather very simple. Okay, say you can write, say in the previous line you have written decrement CX, whatever you want. Say you have written decrement CX, then you are writing jump if parity even, and then you are providing some destination level. So what will this condition check? It will check whether in CX the parity is even or odd, right? So if the parity is even, it will jump. If the parity is odd, it will come to the next line. As simple as it is. Is it okay?
Yes, sir.
Very simple, okay? These are nothing complicated. Now, there is a limitation. All right, so look at the limitation. The limitation is your destination level must precede or follow within 126 and 27 bytes respectively. Like if your destination level, okay, let me open. Okay. So if your destination level is preceding instruction, that means if your destination level is before the jump instruction, then there cannot be more than 126 bytes difference between the and your destination level. And if your destination level follows it, then it cannot be more than 127 bytes. Meaning that, let me show you an example. Okay, see over here, you are having your okay, you are having your jump instruction in line number 15, right? And where is your destination level? In line number 11. So between this, I mean between this destination level and your jump instruction, there can be maximum of 126 bytes. Is it clear?
Yes, sir.
If there is more than 126 bytes, your jump will not work. The same thing, instead of this level having appearing before, say if this level appeared anywhere after line 15, say it appeared in line number 25 for simplicity, just assume over here is your level, then over here the maximum difference can be 127 bytes, not more than that. If the distance is more than 127 bytes, then this jump instruction will not work. Is it clear up to this? বুঝা গেছে?
Yes, sir.
Sir, what does word byte mean here?
How much memory is being allocated, or how much memory you are using in these specific lines between them?
Sir, is it a specific characteristics of the print loop or anything else?
It is a specific characteristics of conditional jump.
Okay, sir.
Sir, can you repeat
Jump,
again?
your conditional jump cannot jump more than 126 bytes. If you remember, your all those instructions are loaded somewhere, right? First class jump instruction thakle, we had to remove everything from the prefetch queue. Do you remember all those things?
Yes, sir.
So this is based on something like that. So if you have a conditional jump, you cannot jump more than 126 or 27 bytes. Okay?
Sir, can you precisely say how can you determine the destination level exactly?
I mean, how many bytes are there between destination level and that?
Yes, sir. How do we determine by the lines we are skipping?
Okay. So
actually, Arif, I want to add just one thing here. Basically, those are the machine code, like move and you're doing some add or sub. All those are translated into machine code. They are of 1 byte or 2 bytes instruction, isn't it? So basically, by that you can assume, and otherwise we do not actually count those things normally. That is the thing I want.
Okay, yeah, that's what I was going to say. Like, if you look at line number 16, okay, move DLX, then you need to know that how many machine bytes does this instruction take. Assume, for simplicity, assume this 16 takes 3 bytes of machine code. Then come to line 17, assume this takes 5 bytes, and so on. So your each instruction will take some bytes. So if after addition it becomes more than 127, then it will not jump. Is it clear?
Yes, sir.
So same thing. Okay, so for understanding, actually we normally do not count. Okay, so we just assume that whether there are a lot of instructions or not. If there are a lot of instructions, we will assume that it is already more than 127. And if there are a few instructions like this example, we assume that this is not more than 127 bytes or something like that. But you can of course come around this problem. Okay, so this was
a question, sir.
Yeah, sure,
The
sir.
previous slide, sir, where you said that if the instruction below the jump instruction is above 127, it will not be completed.
Completed means it will not be able to jump. Like say in line 15, okay, in line 15, say in line 15 you have the jump instruction, and say you have the level in say line 45, say assume, okay. So between line 15 and line 45 you have got a lot of instructions, say about 150 bytes of instructions you have. Then when you are calling the jump from line 15, it will not be able to jump to line 45. Is it understood?
Yes, sir.
Okay, that is the limitation of conditional jump. Your conditional jump cannot jump more than 127 bytes if your jump instruction is following the jump. Sorry, if your destination level is following the jump instruction, and it cannot jump more than 126 bytes if your destination level is preceding the jump instruction or arriving before the jump instructions. Okay. Any other question in this limitation? Okay. So the solution is very simple. We will use unconditional jump. Okay. In unconditional jump, we do not have this type of limitation. When you use unconditional jump, the syntax is jump, just destination level. See, it is simply jump. There is no condition like equal, above, less, carry, nothing. There is no conditional. There is no condition. It is simply jump. So whenever you write jump and then destination level, doesn't matter how many bytes difference is there between the destination level and your jump instruction, it will always jump to the destination level. Clear up to this?
Yes, sir.
Yes, sir.
Let's take an Bujine, can you? Yeah, of course you can do multiple jumps, no problem. Look at an example, okay? I think this one will be clear. Okay, say assume this is one of your codes like top. Okay, assume this is your label, right? It is ending with a colon, so you already know that this is label. Then you have got some code over here, whatever instructions you want, you have over here. Then you are decrementing cx, jump if not 0. So as long as the value of cx is not 0, you will keep on jumping to top. And if the value of cx becomes 0, then it will move over here, that ax will be, bx will move to x, simple. So now see, the problem is, but the body of the loop contains so many instructions that the label top is out of the range for jump not 0. That means what? Over here, you have got more than 126 bytes of code. So what will happen? This one will not be able to jump over there. So to solve, we can write something like this. So your label is still as it is. Okay, wait. So this is your level, same level. Now over here you are writing decrement cx, all right. Now you are writing jump not 0, you are writing bottom. Instead of top over here, you are writing bottom, and this bottom level you are providing very close. So with this instruction, so it will now directly jump to bottom. In bottom, you are just writing jump top without any condition. So since this is unconditional jump, doesn't matter how many bytes are there, it will directly jump over here. Is it okay? And see, if the condition is violated, that means if it becomes 0, then it will directly jump over here. I mean, it will go to jump exit, and your exit will contain these instructions. So see whether it is clear or not. Very simple actually.
Yes, sir.
Any question, anyone, please do ask. Karo kono question ase?
Sir, can you repeat this portion, sir, about the jumping?
Yeah, of course. See, what is the problem we are facing in conditional jump? In conditional jump, if within the body of the loop, you have more than 126 bytes of code or memory allocated, then when you write jump not z or jump not 0 to top, it will not jump over here.
Yes,
because
sir.
it is outside the range. So to solve this problem, up to this is very, I mean, up to this, the code is exactly similar to here. See, this one and this one is exactly similar. Now jump not 0, instead of top, you are writing bottom. And this is another label. You are providing this label very close to this instruction so that it is within the range. So whenever this condition is true, jump not 0, it will jump to bottom over here. Now in this label, you are writing jump top. See, this is unconditional jump. So in unconditional jump, you do not have any limitation of bytes.
Yes, sir.
So it will always jump over here, jump top, right? It will execute this portion of the code now. So what actually is happening, see, if this condition is true, you are jumping over here and you are jumping over here. So what is happening? If this condition is true, you are basically jumping to top. That is what you actually wanted to do over here.
Yes, sir.
But you are having, you need to do a double jump. Instead of jumping directly, you are jumping to bottom. Then from bottom, you are jumping to top. Instead of doing directly, you are having double jump. That is the only difference, nothing else.
Okay, sir. Understood, sir.
Any other question, anyone? Okay.
No, sir.
Like I said, this again goes to fabrication process and the designers and all. They impose all these limitations for smooth operation of the microprocessor. I don't know the exact reason why this limitation has been imposed.
So maybe the memory allocation of the prefetch queue would matter, sir.
Might be, I don't know. For conditional jump, since it also needs, see, for conditional jump, your processor will check the status of the flags, okay? So it is also related to flags. So maybe it has something to do with the flags as well. I'm not sure, okay? But definitely there is some reason, because the only difference I can find between between conditional jump and unconditional jump is that your unconditional jump does not depend on the status of any flag, but your conditional jump depends on the status of the flags. That is how your microprocessor or your processor determines whether it will jump or not, right? Do you remember? So
Yes,
maybe
sir.
it has something to do with the flags, but I don't know the exact answer, okay? Okay, let's move on. Now, this is a jump for characters. If you know, each character has a ASCII value. I mean, it was already covered in your previous labs, isn't it? You already know. Each character has a ASCII value. So if your sign bit is 0, I mean, if the ASCII character, I mean, if the ASCII value of a character, the sign bit is 0, then you can use either signed jump or unsigned jump. That is totally up to you. But if you go for extended ASCII characters, that is from 80 to FF, you see that in all of these cases, your sign bit is 1. So make sure in all these cases you go for unsigned jumps, because these are ASCII codes for your characters. So you do not need to consider the sign. Are you getting my point?
Yes, sir.
So whenever you go for characters, I mean jump for characters, it is safe to say that always use unsigned jumps. Do not use signed jumps, because we do not go for signed interpretation of ASCII numbers. We always go for unsigned interpretation of ASCII numbers. So it is better to use unsigned jumps in all the cases of the characters. All right? Is it clear? Is this portion clear? Please let me know.
Yes, sir.
Can you please repeat it? My internet got disconnected.
Okay, no problem. See, if you remember, all the characters are represented by their corresponding ASCII numbers. So if the ASCII number of any character has a sign bit of 0, sign bit means the MSB. If the MSB is 0 of any ASCII number of a character, then you can use both unsigned jump or signed jump. Because if the MSB is 0, your unsigned jump and signed jump will always mean the same thing, isn't it? Like if you go for an unsigned number like 7FFF, no, 7 in 7. Okay, if you go for 0AH, so 0AH has the same signed interpretation and unsigned interpretation, right? So the same thing, that is what I'm saying. If your MSB is 0, you can go for either signed jump or unsigned jump. That is totally up to you. But if you go for extended ASCII characters, where the ASCII codes are from 80H to FFH, in these particular cases, you see that your MSB is always 1. That is, your sign bit is always 1. So in all those cases, always go for unsigned jumps. Because if you go for signed jumps, your processor will consider that as a negative number. But you see, your ASCII codes are not negative. Your ASCII codes are never negative. Your ASCII numbers are never negative. Okay. So you always go for unsigned jumps, because we are going for unsigned interpretation of those ASCII codes. Am I clear? বুঝতে কি পারছো?
Yes, sir.
Is it like, sir, for ASCII code will go for unsigned number always?
Yeah, for characters actually, for characters, not always for ASCII. It is better to specify characters. Whenever you want to go for characters, it is safe to always go for unsigned jumps. Okay, yes, moving on. Now we will go for branching. Okay, like branching, it will based on different conditions. Your program will take different paths. Simple. This is known as branching. So let's look at the examples. From the definition, the examples make it actually much clearer. Okay, so this is the pseudocode. So we are trying to execute the if then condition in C programming, whatever you did in if and then. So this is the pseudocode. If ax is less than 0, then replace ax by minus ax. That is what we want to do. Is the pseudocode clear, everyone?
Yes, sir.
So what we will do, if actually what we are trying to do, if ax contains a negative number, then what we will do?
We'll mod it.
What will we do? Tell me, what will we do?
Sir, complement, we take complements.
We'll take the negative of x.
Exactly, we'll take the negative, okay? See, now look at this code in assembly language and tell me whether you understand or not. Just tell me. Because in the comment section, this is also already explained. So I'll be just reading it. So just tell me whether you understand or not.
Yes, sir.
Are you sure you understood?
Yes, sir.
So if there is a jump, that means what? The condition is true or false?
Sir, true, sir.
The condition is true. So if the condition is true, your ax is less than 0 or greater than 0, if the condition is true.
So greater than.
Sir, greater than 0.
Exactly. If the condition is true, that means your ax is greater than 0. Your jump says jump if not less. So simplifying it, it is jump if greater. We could have simply written jg, right? Jump if greater, right?
Yes, sir.
Yes, sir.
That would have made
Yes,
it
sir.
much easier, isn't it? Are you সহজ হতো না jump if greater লিখলে?
Yes, sir.
Yes,
But
sir.
sir, the equal one will be
No,
equal টা বাদ পড়ে যেত স্যার।
এখানেও তোমার ইকুয়াল নাই তো, তোমার তো লাস্টে ই নাই। জাম্প ইফ নট লেস জাস্ট।
নট লেস মানে তো স্যার হচ্ছে মানে কম, মানে ইকুয়ালটা হিসাব হচ্ছে না।
You are right.
করলে তো 0ই থাকবে।
No, actually he is right. So when you are writing jump if not equal, it will check with the jump if not less. We're actually checking for the equal as well. He is right. Because jump if not less means even if it is equal, it is not less, right?
Yes, sir.
Yes, sir.
He is exactly
Particular
correct.
problem, it's not necessary to give the equal.
Yeah, you might avoid. That is actually up to you. But just tell me whether you understood the pseudocode and the code in assembly or not. Is it understood?
Sir.
বুঝা গেছে সবাই বুঝছো?
Yes, sir.
Okay, what I'm trying to say is that we actually do not have the exact if then structures in assembly language, but using these jumps we can execute all of those instructions. That is the main idea. Like see, in this case you do not actually have if then structure like in C programming, but using this jump instruction you can execute similar things in assembly language. Is that part clear? Okay, if so, now tell me, can you execute this code in assembly language? This pseudocode? Can you?
So we can try.
Yes, sir.
Sir, I think yes, sir.
I think you can. Okay, let me show you the solution. Now just look at the solution. Also the comments are given. So just tell me whether you understood or not.
Sir, is it jump if not equal and below?
Yeah.
Below and equal.
Below and equal. Jump if not below or equal.
Sir, এটা একটু explain করে দিলে ভালো হয়, sir.
আচ্ছা ঠিক আছে, okay, thank you. Okay, so what is the condition? The
Sir.
pseudocode says we will check whether AL between AL and BL. So if AL is smaller than BL or equal, then we will display the character in AL, else we will display the character in BL. So what does it conclude? Whichever between AL and BL is smaller, we will display the content of that register, right?
Yes, sir.
If AL is small, then we will display the character in AL. If BL is small, we will display the character in BL, right?
Yes, sir.
Okay. So move H2 is simple for preparing to display. That is very simple. Now you are comparing AL and BL. So basically you are executing AL minus BL. Now you are saying jump if not below or equal. Not below or equal, meaning what?
Meaning AL should be greater.
Yeah, exactly. AL should be greater. So if AL is greater, I mean this condition, when will this condition be true? Tell me.
So if AL is greater.
If AL is greater, is that so?
Sorry, it is jump if not equal, below or equal.
Yeah,
So
jump
if
if not.
AL is greater, then sir it will jump.
Okay, so this jump will occur if AL is greater, right? This will be true if AL
Yes, sir.
is greater. So
Yes, sir.
if this is true, if AL is greater, we will print what? The content of AL or BL?
Sir, BL, sir.
Exactly, because whichever is smaller, we will print the content of that register.
Yes, sir.
This condition is true if AL is greater. So assume AL is greater. So the condition is true. So
Yes,
we'll
sir.
jump to else. That means we will come over here. See what you are doing? We are moving the value of BL in DL. Do you see?
Yes, sir.
Then we are coming over here. So we are displaying the content of BL, right?
Yes, sir.
So when will this condition become false? This condition will become false when AL is smaller, right?
Yes, sir.
Then this condition will be false. Did you get the point?
Smaller or equal, sir.
Yeah, smaller or equal, whatever. Yeah, smaller or equal. Then this condition will be false, right?
Yes, sir.
Yes, sir.
If the condition is false, then there will be no jump. If there
Yes,
is
sir.
no jump, we need to print the content of AL, isn't it?
Yes, sir.
So see, it will come to this line. You are moving AL to DL.
Yes, sir.
Now we have got another jump instruction over here, because say if you did not have had this instruction, your processor would have gone to this line after this, isn't it?
Yes, sir.
Because your processor executes line by line, it will not check for this label or anything. After executing this line, your processor will execute the following line, whatever line that is. So if this jump display was not there, your processor would have directly moved over here. So that's why you are giving a jump over here, so that from here you are directly coming to this display. Now when you go for int 21H, you have AL in this DL. So now you will print whatever is there in AL. Is it clear now?
Yes, sir.
It's okay, sir.
It's okay. I think if you want, you can code it in a much simpler way. Like you can simply change these conditions or something like that. No, but I think this is much simpler actually. This is not complicated at all. Is it okay, everyone? Understood? If you do not understand, please let me know. I can explain it again and again. But please do understand. ID 118. সে কি আসছে নাকি এখনো আসে নাই? Fariha, are you there?
Yes, sir, I am here.
তখন কি ছিল?
Sir, I was outside.
Outside মানে বাসার বাইরে?
No, sir. My dad called. I had to.
Oh, okay, fine. Okay, no problem. So, did you understand?
Yes, sir.
Okay, let's move on. So, do you remember your cases in C programming?
Yes, sir.
Okay, so this is a case like case X. So if the contents of X is negative, then we'll put -1 in Bx. If the value in X is equal to 0, we need to put 0 in Bx. And if the value of X is greater than 1, we will put 1 in Bx. Very simple. So can you execute this in assembly language?
Yes, sir.
Yes, sir. I think you can. So let's take a look at this one. See whether you understand it or not.
Yes, sir.
So what is the only idea over here? In every level, we are using a conditional jump. That is the only difference. See, in
Yes, sir.
every level, we're executing a conditional jump so that if we come in this level and this level will not be executed, right? That is what was with case. In C programming, this thing was automatically done. Whenever this condition is true, these two were automatically false. So you did not have to worry about this. But in assembly language, that is not the case. So in each level, at the end, you have an intentional unconditional jump so that if this condition is true, it will not come over here. So, and from here you can see that your processor will only come over here if this is false. So if it comes in 0, this one is automatically skipped. Did you get the point?
Yes, sir.
Your processor will only come in this 0 level when this one is false. So any of these 3 level has to be true. It cannot happen that all of these conditions are false. It simply cannot happen. So any of these 3 conditions must be true. That's why at the end over here, we do not have an intentional jump. Am I clear, everyone?
Yes, sir.
Okay. So do I need to explain anything over here?
No, sir.
No, sir.
No,
Very
sir.
simple. আজকের ল্যাবে এখনো এমন কিছু পাইছো যেটা খুব কঠিন?
No,
No,
sir.
No, sir.
So that is the thing, okay? Robuel is in charge of teaching you the hard things. I will just teach you the easy things. That is how it works, okay? Okay, let's move on. Now we need to use OR, like case AL. If in AL we have 1 or 3, we will display O, I mean signifying OR. If we have 2 or 4, we will display E, that is even. Simple, you need to execute it with jump. So this is the code. You will need a lot of jumps actually. Look at the code and tell me whether you understood or not.
Yes, sir.
So again, look at this. The idea is that assume for simplicity, your AL has the value of 3. Just assume. So this condition is becoming false. This condition is becoming true. So these two are automatically skipped and it will come over here. So this one is being executed. After this, it will directly go to display. So as simple as it is, right? So assume AL has the value of 4, whatever you want. So this condition is false, this condition is false, this condition is false, this condition is false. Sorry, this condition is true. This condition is true. So it will directly jump over here. So this one is automatically skipped and it will come over here. So it will move the value E in DL, then it will come over here. Very simple. Is it understood?
Yes, sir.
Yes, sir.
Now in AL, you have got 7. So what is happening? This is false, this is false, this is false, this is also false. So see, if all are false, only then you will come over here. That is end case. So it will simply not display anything. It will directly jump to end case. Simple and precise. Understood?
Yes, sir.
Okay, let's move on. আজকে ল্যাব অনেক তাড়াতাড়ি শেষ হয়ে যাবে। Similarly, you can go for AND also in assembly language. Like if the content in AL is a capital letter, then it will display, otherwise it will not. Simple. So now tell me someone, why are we moving 1 in H? Tell me. So far in all the examples, we had 2. Now you see over here we are moving 1. Can anyone tell me why?
Yes, sir. 109.
Exactly. This is the first instruction in the pseudocode. We need to read a character. So if I read a character using H1 and in 21H, where is the character stored?
In AL.
Exactly. By default, it will be stored in AL. Very simple. So see, now you are checking. Compare AL with capital A. So if it is not greater, that means if the value in AL is smaller than capital A, that means it is not a capital letter. So you will directly jump to end if. If this condition is true, now you will check, that means the value in AL is greater than this capital letter A. Now you have to also check whether the value is smaller than capital Z or not. So if it is smaller than capital Z, then you will come over here. But if it is not smaller, you will directly go to end if. Okay. So if these two conditions are simultaneously satisfied, only then this line and these portions will be executed. Is it understood? See, I have not given comment over here because you have already understood the previous one. So this one should be self-explanatory. বোঝা গেছে?
Yes, sir.
118 বুঝছো?
Yes, sir.
তাহলে আমাকে বলো এই লাইনটার মানে কি? JNLE এটা মানে কি?
Sir, it checks if it is sir, greater than this or
কে কার গ্রেটার অর লেস আমাকে এটা বলতে হবে।
sir
আগে বলো JNLE এটার ফুল ফর্ম কি? What is the elaboration of JNLE? Come on, you said you understood. See, this is the problem. Even if you do not understand, you do not respond in the class. I told you 1,000 times. If you do not understand, please let me know. Please let me know.
Yes, sir.
And কি বলো বুঝছো?
So পুরোপুরি বুঝিনি।
পুরোপুরি বুঝ নাই। কোনটা বুঝো নাই সেটা তো বলতে হবে।
So with which one we compare?
With which one we compare? এখন আমাকে বলে এতগুলো एग्जांपल হয়ে আসলো প্রত্যেকটাতে এই জিনিসটা ছিল এর মধ্যে তুমি একটা एग्जांपलও বুঝো নাই।
So
okay, see what is JNLE? JNLE is jump if not less or equal. This is the full form. That is the first thing. These jump instructions always follow what is there in the previous line. In the previous line, you have compared AL with Z. So you are comparing AL with Z. So you are saying not less. That means you are checking whether the content in AL is less than Z or not. Whether the content in AL is equal to Z or not. Is it okay?
Yes, sir.
Assume in AL you have got P, capital P, assume. Okay. So what you are comparing?
Yeah.
You are comparing the content of AL. That means you are comparing P with Z.
If it's equal or less than
now
Z
tell
or
me,
not.
Now tell me, if AL contains P, then this condition, this jump instruction is true or false?
So it's true.
Why is it true?
So if it will jump if it is not less or equal as
So wait. So I said not less. So is P less than Z? P is less than Z or greater than Z? Tell me. কোনটা বড়? P বড় না ছোট Z বড়? কোনটা বড় বা কোনটা ছোট?
so Z is greater.
Z is greater. So you are telling not less. So what you are saying? You are saying P is not less than Z. Is it true? এই কথা আমি যেটা লিখলাম, is it true?
No, sir, it is false.
So why are you saying the condition is true?
So I didn't understand it first.
Now did you understand?
Yes, sir.
The value of AL is P. Then you are, for this particular instruction, you are saying something like P is not less than Z. So is it true or false?
It is false.
It is false. So this jump will not be executed. So
Yes.
your processor will come to this line. Is it okay?
line. Yes, sir.
Sure.
Yes, sir.
Okay. If you understood, now tell me, in AL we have got P. Tell me whether this condition is true or false. This one is jump if not greater or equal. Okay, jump if not greater or equal. So tell me whether this condition is true or false.
So this is true.
This is true.
Yes, sir.
So you are saying P is not greater then
So, sir,
your
did you
computing
say
will be
greater? I thought you said less. So if it's greater,
why you
then
yeah, if it is greater
yes. So if
then it is true
it's
or false.
it's false.
So see, this is the maximum or this is the best I can explain. Even if you can't understand after this, I think I can't do anything else. Others,
Sir,
did you understand everyone? Bolo, bolo, bolo. 118, bolo.
so I understood it now.
Okay, so I hope you understood the previous examples also. Okay, so let's move on. Now we will go for loop. Should we take a break
Yes, sir.
before going to loop?
Yes, sir. Yes, sir.
Yes, sir.
Okay, this is now it is 12:16. So get back at 12. Okay, it already became 12:17. Okay, get back at 12:21. Okay.
Okay, sir.
Again at 12:21 we'll see.
Okay, sir.
Okay.
009. 009. I think she's
Yes,
here.
sir. Yes, sir. I'm
Okay,
here.
okay. 13.
Yes, sir.
Let's continue.
Okay, so let's start. Okay. All right. So we are almost at the end of our class. Okay. A few minutes and then it will end. Don't worry. So the last thing we have to discuss is the looping structure. So you already know what a loop is. A loop is a structure that is repeated. I mean, based on you, how many times you want it to be repeated. So it will be repeated based on your certain conditions. There are two types of loops, for loop and while loop. So we'll just take a look at the example and we'll be done. Is it okay, everyone? Very simple, okay? There is nothing over here complicated. So you already know what is a for loop. So this is the syntax for loop in assembly language. So loop LOOP, by default, it is a built-in command in assembly language that is responsible for going to a loop. So if you write loop, look at the CX register. Your CX register automatically decreases every time you execute this loop command or loop instruction. That is only difference over here. Okay. So whenever you execute this, okay, am I audible? I don't think so.
No, sir.
Am I audible
No,
now?
sir. It is disrupting, sir. Your voice.
Now it is okay. Now it is okay.
Now it is
Yeah,
okay,
yeah.
sir.
Okay. So as I said, loop is a built-in assembly language instruction. The thing is, your CX register is associated with this loop instruction. So every time you execute this loop instruction, the value of your CX register automatically decreases by 1. This is the main difference between this loop instruction and previous all other examples or instructions that we saw in today's class. In other cases, every time we used jump. So jump does not affect any register just by calling jump actually. You need to either increment or decrement. But in this loop instruction, whenever you call this loop instruction, it automatically decreases the CX register by 1. All right. And see, look at the third point. So it will keep on checking. So as long as the value of CX is not 0, your loop will always transfer the control to the destination level. It will keep on transferring the control to the destination level as long as the value in the CX register is not 0. So assume in CX you are putting a value of 5. So after calling this loop or after executing this loop instruction 5 times, your CX will automatically become 0, and then your control will not be transferred to the destination level. It will go in the next one. And also this condition is there. It cannot precede or follow by more than 126 bytes. Actually, it is precede because your loop must come, I mean, the label for loop, the destination label must come before the loop command. Because if it comes after the loop command, then there is no way to call the loop again. So as simple. Okay, let's take an example. Is it understood up to this?
Yes, sir.
Yeah, you can say that it is actually kind of a conditional jump with an auto counter of CX register. You can say that. Okay, let's take an example. So this is a pseudocode of an algorithm. For 80 times do display asterisk and end for. That means for 80 times I need to display asterisk. As simple, I have to print 80 stars. So this is the code in your actual assembly language. Go through the code and tell me which portion you did not understand except line 10. Apart from line 10, tell me which portion you did not understand. Okay, so still
Sir,
let's
it
explain for
means
the sake of explaining. So initially CX has the value of 8, your DL contains your asterisk. I told, okay, H has the value of 2. I told you to forget about line 10 for the time being. It will come to line 48 in 21H. In 21H will check for the value in AH. The value is 2. So it will check for the value in DL. The value is star. So 1 star will be printed. Now it will go for loop. Once it finds loop, the value of CX automatically becomes 79. Again, it will go for int 21. It will see the value of H is 2. The value of DL is asterisk. Another asterisk is printed. Again, it will go to line number 15 loop. So value will automatically become 78, and this process will keep on going. Finally, it will go to skip. These two lines will transfer the control and your code will be ended. Is it understood?
yes, sir.
Okay. Now, can anyone tell me why this line is there?
Sir, jump if CX is 0. Sir, jump if CX is 0.
Yeah, why do we need to give that? Jump if CX is 0. The loop will continue for 65,500, and what is the largest number that it can hold? 655?
6, 8.
Whatever. Yeah, 36 most probably, whatever. So if say instead of 80, your CX contains 0, say for some particular reason, if CX contains 0, then if you do not give this line, see, it will come over here in 21. When you give loop, this 0 will be decremented by 1. So decrementing it by 1 is -1. If you take -1 in binary and give that unsigned interpretation, you will end up getting this number. Am I clear? আমি যেটা বলতে যাচ্ছি, if you have initially the value of CX, assume the value of CX is 0 and this line number 10 is missing. Okay, so CX is 0, you come over here in 14 int 21H and you go for loop. So loop will do what? Whatever is the value of CX, it will first thing it will decrement by 1. Okay, then it will check whether it is 0 or not. So the value of CX is 0, so it will decrement by 1. It is -1. This loop does not know what is -1, so it will check the binary. It will convert that binary to unsigned interpretation. It will end up getting 65,536 or something, whatever is the number. I don't know the exact number. So it will convert to that number and it will keep on running up to this. Then again, when the value of CX is actually 0, then it will increment it to 0. It will understand now it has become 0, so it will not go again. Understood now?
So Arif, I have one question here.
Well,
so if we are confirmed that this CX value is not 0, so we can skip number 10 number.
Yeah. You can skip number 10 if you know that CX is not equal to 0. This particular line JCXZ, this reads as jump if CX is 0. So if and only if CX is 0, only then it will jump over here. See, for this particular scenario, when you are giving 80, once you enter line number 14, you will never get back to line number 10. So you don't have to worry about this. Once you are in line number 14, every time line 12, 14, 15, only this portion will be executed and nothing else. But this one is given as a precautionary move. If it at any time accidentally your CX contains 0 initially, then so that we do not enter an infinite loop, this specific line is given. Is it okay?
Sir, what if we give a negative number at CX?
What if you give a negative number is 6? I don't think the loop will work. It will not work.
Why, sir? Then why it will work for 0?
Why it will? Okay, let's take an example. Okay, since you said, so let's see what happens. Let's go to, okay, let's do it. Let's see what happens. Actually, I never tried it, so let's try. Okay, let's open the code for count. Okay, yeah. Let's go for print character. Okay, so this is the code that you just saw. So you are saying, what if we move over here, say -2, right?
Yes, sir.
Okay, let's see what happens. So okay, this is the code. Okay, let's go to single step. All we are interested in looking at the value of the CX register. Okay, so let's go to single register. See,
Sir,
what is the?
we're not seeing the output.
Are a full screen share?
Oh, acha. Wait. Okay, is it visible now? Okay, so this is what we are saying, right? -2. Okay, so let's write. So all we are interested is we need to look, check the value of CX every time. Okay, that is what we are interested in, because your loop will affect the CX register only. So let's go a single line. So after you enter -2, it becomes to FFFE. So what is FFFE? Okay, wait. Just a second. Okay, so what did we get in hex 16-bit? We got FFFE. So what is the unsigned interpretation? It is 65,534. So let's see what happens. I still don't know what will happen. Okay, let's go.
Can run a single step, yes.
Yeah, single step. H2 jump if CX is equal to 0. So it is not supposed to jump. Yeah, it did not jump. Okay, it will print 1 star if I execute this in 21H. Yeah, 1 star is being printed. Now let us go to the loop. Okay, now see what is the value of CX? FFFD. So what is the value of FFF? It was 534. It was 534. So now it is 533. So are you getting what will happen?
Yes, sir.
So it will keep on executing for that amount of time. So now if we go for run, so it will keep on running.
So, sir, that extra line is not helping.
Yeah, that extra line is not helping if the value is negative. That is true.
Yes, sir.
See, the way these things are designed is for unintentional errors. Okay. Now, they normally thought that you will always initialize CX, but accidentally, if in some previous cases, you are already running a loop and your CX has already come to 0. After that, if you try to execute another loop, then it will create the problem, right?
Yes, sir.
So that is why this thing is actually designed, because they never thought that there will be a student who will say, sir, minus dile ki hobe, because you are challenging the system actually. Okay. So this is designed for those particular cases, because it is very obvious that in one program, you can have more than one loops or a number of loops. So what will happen if you executed a particular loop and then you are trying to execute another loop and you forgot to initialize your CX? So for those particular scenarios, this line is given. Am I clear?
Yes, sir.
Yes, sir.
Bujha gechhe everyone?
Yes, sir.
Okay, anyway, thank you for the question, because logically this is supposed to happen, but since I never tried it, so I could not give you the answer. But the logic is same. right? The logic is remaining the same.
Yes, sir.
Okay, let's get back. Okay, so this was your for loop. The code was given, the output was given. Very simple. This is your while loop. Okay, cartoon is there. There is a reason why that is there. We will get back to that later on. So look at the pseudocode. So initialize count to 0. Fine. Read a character. All right. While the character is not equal to carriage return, this sign. Okay, wait. This sign means not equal. Okay, while the carriage return is not equal to or greater or less than, as greater than less anyway, so we will keep on counting. That means whenever you will press enter, it will show how much you have counted. So this is your while loop. Did you get the question? I mean, your processor will keep on reading a character until and unless you are pressing the enter button. Once you press the enter button, it will end the condition. Okay, it will end the while loop. Is it okay?
Yes, sir.
Now look at the code and tell me whether you understood the code or not. Okay, let's do the code together. I think okay, it will be easier. Okay, initially you are moving the value in DL to be 0. All right, AH is 1 for reading a simple character, single character. Okay, so in 21H you are reading a character and you are storing the character in AL. Now you are comparing AL with ODH is carriage return or enter, if you remember, right? So you are comparing with enter. If it is equal, it will jump to end while. Okay, assume it is not equal, so it will increment DL. So now DL will become 1. Again int 21H, so you will read another character. So say another character has been given and you will jump to while. Again you will come over here. You will compare that character with enter. Assume this is not again enter. So this condition is false. Again it will increment to 2 and this process will move on. When you press enter, this condition will be true. So jump equal end while. So it will come over here. It will come over here. Whatever the value you had in DL, yeah, that will be moved in BL.
Yes, sir.
Okay, so you are storing the value of DL in BL temporarily. Why? Because you are giving an enter and a line feed and a carriage return in these two lines. So this one modifies your DL, right? So you are going to the next line. Now whatever you had in BL will now be transferred to DL. If you give int 21H, you see AH contains 2. So whatever is there in DL, that will be printed. Am I correct? If that is the case, see now this is why this asterisk is there. This cartoon is there. Now say I'm writing how space R space U. So if this is the case, see what will happen. So initially DL is 0. Forget about all this thing. Look at DL. Initially DL is 0. Okay, you are coming over here. What you are doing? You are writing H. Okay, you are writing H. You are comparing H with enter. Is it equal to enter?
No, sir.
It is not equal to enter. So it will not jump over here. It will increment DL. So now DL will become 1. Int 21H. It will take another character. So it will take this character O. Fine. It will jump to while. It will come over here. Compare O with enter. Is O equal to your enter? It is not equal. So again DL will be incremented. Now DL will be 2 and this process will go on. So how many characters are you giving actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? But we are starting with 0. So maybe 11 most probably. Because if we keep on going, how many characters we will end up getting? Tell me. 11 or 12? Tell me again. It will be 11 or 12? You can count and tell me whether this will be 11 or 12. একজনও পারবা না? হ্যাঁ 12 হবে? Okay, we will check it. Okay, assume it is 12 for the timing. Okay, say it is 12. After this, you are pressing enter. So if you press enter, now you compare with ODH. Is it equal to ODH? 0 DH. Yes. So the condition is true. So it will. Sorry. So the condition is true. So it will come over here. Now see, you said it will go up to 12. So DL has 12. So 12 will be moved to BL. So now BL also contains 12. Okay, now you are giving a carriage return and a line fit. Fine. Whatever you had in BL is moving to DL. So now DL also contains 12. Now you go for int 21H. Int 21H will look for AH. Your AH has 2. So now it will look for DL. Whatever is there in DL, it will be printed. So in this line, what will you get? Will you get 12? Tell me, will you get 12? Huh? Yeah, definitely. See, you are in this line, right? After in this line, what did you do? You gave a line feed and a carriage return. So you are coming over here. That means you are coming in this portion. Over here, you are coming. Over here, you are printing. You are moving 2 into AH. So you are trying to print something. What you are printing? Whatever is there in DL. So whatever you had in DL, you temporarily held it in BL. Finally, you converted. You transferred that content from BL to DL. Now in this line, you are trying to print the contents in DL. You know that DL contains 12 because you had 12. So tell me, how much will be printed over here? Will it be 12? Is there anyone with no? Is there anyone?
Sir, will it be 12 plus 1 or?
Will it be 12 plus 1? No, that is not the answer. Is there anyone else? Will it be 12? Come on, think. You should be able to answer this.
So no, it will be 13, I think.
If they are so into the jump and compare.
Not exactly. It is not related to 11, 12, or 13. Whatever is there, assume I am telling you that it is 12. That is for 100% sure. Your DL contains 12. Assume. So will 12 be printed?
Yes, sir.
Anyone
No,
with a
sir.
Okay, what will be printed? If 12 is not printed, then what will be printed?
Then it will 11, sir.
Anyone?
Sir, 12, sir.
Huh?
12, sir.
12 print hobe?
Sir, it will be something will be printed because age is 2.
Something will be printed. Definitely something will be printed. Say something
It will print a character.
Wait. Key, it will be?
Print a character.
It will print a character. Okay. How will you determine which character will be printed?
ASCII code, sir.
Okay, ASCII code. ASCII code of what? তোমার answer almost there. Just try to think. আরেকটু।
Sir, 12 এর ASCII code যেটা
Exactly. What 12 এর ASCII code যেটা সেইটা print হবে as simple as it is. So it will print you this one. Okay, let's take a look at let's take a look at the ASCII characters. Okay, if we go to this process over here, ASCII codes, look at 12. You see this sign? Can you see?
Yes,
Can
sir.
you see?
Yes, sir.
Yes, sir.
So this one will be printed. Okay, you cannot print 12. Your processor is storing 12. That means what? It is storing it in binary. So if it converts, it will always print the ASCII character. I think this thing was discussed. That's why is it clear, everyone? আচ্ছা কে বললো ASCII character হবে ফাইনালি না শুরুতে কে বলছিল একটা ক্যারেক্টার প্রিন্ট হবে? 109 রিয়াদ গুড। না আজকেও একটা আনসার করছে, পরে আর জিজ্ঞেস করা যাবে না রিয়াদ রে। Alright, is it clear up to this while loop? Everyone, is it clear?
Yes, sir.
While loop is nothing. This is actually equivalent to whatever jumps you have learned previously. The only difference was your for loop. The loop instruction. But this is actually your jump, nothing else. Okay? Now this is your self study. Okay, these are very simple. Repeat loop, repeat. I mean, these all are done using jump. Nothing. Programming with high level structure is what we just did, and these are your tasks. Try to do it. These are very simple tasks. So that will be all. So if you have any question, please you can ask. If you have any question in today's class, feel free to ask.
So one thing about the previous day lab report, there was one task in that it was asked that we should make a beep. So I coded it, but I did after running the code, I did not see any difference. What did it do?
ভলিউমটা একটু বাড়ায় রাখো, আর এই যে বিপ হচ্ছে 007, ঠিক আছে, ভলিউম বাড়ায় রেখে রান দিও, it will sound, there is no doubt. I mean, if I can, আমি জানি না, if I can share my sound experience, wait, the code is there. I think this is the first code. Oh no, this is not the first code. I forgot the first code that I made. If I could have opened that, I think there was a sound.
আরে ওই যে লুপেরটাই বের করে ওখানে এইচটিডি এর জায়গায়
এই যে এইটাতে তো সাউন্ড ক্রিয়েট হয়, কিন্তু এটা কি আমি দিলে কি এরা শুনবে সাউন্ডটা?
দেখি
Okay, let me run. Just see whether you can. Just try to listen. Okay, I don't know whether you can listen or not. শুনছো একটা সাউন্ড হয়েছিল যে?
Yes,
sir. Beep শোনা গেছে।
Yes, sir.
Yes, sir.
So that is your beep. Okay. So this was your first code that I showed you at the beginning of today's class. Any question you can ask.
Sir, about previous class of lab attendance, did you take attendance or something?
Attendance goes to Robiul. Robiul, please.
Sir, মানে আমি জি স্যার 16 আমি গত ক্লাসে আমি ফুল ল্যাবতে অ্যাটেন্ড করছিলাম স্যার, এন্ড মানে আমার অ্যাটেন্ডেন্সটা নাই।
তুমি তো আজকে অ্যাটেন্ড, মানে যখন আমি ডাকছি তখন ছিল না।
স্যার আজকে আমার স্যার নেটওয়ার্কে অনেক প্রবলেম ছিল, আমি তো ব্রেক নিতে গেছিলাম, তারপর আজকে লোডশেডিং ছিল আর নেটওয়ার্ক প্রবলেম ছিল, আজকে আমি স্যার অ্যাটেন্ড করতে পারিনি।
প্রিভিয়াস ক্লাসে আমি অটোমেটিক যেটা থাকে সেটা চেক করে তোমারটা দেখবো আর কি। ওকে, if you were present I can find there. Okay, and also you are not present in lab 2 also. You try to be a bit consistent. I do not know how you are missing those attendance.
Is there anyone with any question? You can ask.
Sir, what will be the upcoming topics in the next class?
Upcoming topics কেন আগে থেকে পড়ে আসবে নাকি?
স্যার একটু আইডিয়া না থাকলে স্যার ক্লাসে একটু সমস্যা হয় স্যার।
একটু আইডিয়া না থাকলে ক্লাসে সমস্যা হয়। নেক্সট টপিক হবে হচ্ছে, আচ্ছা রবিউল, এটা কি ওদের লাস্ট ল্যাব মিডের আগে?
হ্যাঁ ওদের বলে দিছি, মিডের পরে ওরা ফার্স্ট উইক থেকে আসবে।
আচ্ছা, মিডের পরে তোমাদের ফার্স্ট টপিক হবে হচ্ছে চ্যাপ্টার 7 of the Marut's book. That is basically your shift instructions and rotate instructions, all those things. আমার এক্সাক্ট মনে নাই। Okay, I can check. Okay, logic, shift and rotate instruction. Okay, chapter 7 of Marut's book.
And also I'll suggest you to go through the book also for chapter from the chapter 1 to chapter 6 also.
I think just that is better. That is better what Robiul is saying. Instead of reading chapter 7, what you can do is at least go through all the previous labs and try to go through the book as well. That will give you a much better base, okay, to understand the next labs. যেটা পড়াবো সেটা আগে থেকে পড়তে হবে না, বাট যেগুলি পড়াই গেছে এটা আগে থেকে প্রিপেয়ার রাখবা, তাহলে পরেরগুলো বুঝবা। Okay, yeah, I think that will be all. If you want, you can leave.
Assalamu alaikum, sir.
Assalamu alaikum.